So here we're going to have to use the equation of continuity first. The cross-sectional area of a pipe times the velocity in that area equals the cross-sectional area of the second section times the velocity in that second section. We're trying to find the velocity in the second section of the pipe. We know that d sub 1 is going to be d sub 2 over 2, which means that r sub 2 is simply going to be 2r sub 1. Given this, we can tackle this. So this is simply going to be v sub 2 equals a sub 1 v sub 1 divided by a sub 2. The cross-sectional area of any pipe is simply going to be pi r squared. So this would simply be pi r1 squared. Apologize. And then we have v sub 1 divided by pi r sub 2 squared. Now, we know that pi r sub 2 squared is going to be 2r sub 1. So we can cancel this out and cancel the pi's out and plug in for our constants. So v sub 2 will simply be r sub 1 squared. And then v sub 1 is going to be that velocity, which is going to be 3.00 meters per second, divided by 2r sub 1 squared, because the radius of the second section of this pipe is going to be twice the radius of the first section of this pipe. This is going to be 3 over 4, given that the r sub 1s cancel out. So the velocity in the second section is going to be 0.75 meters per second. Now, after this, we can now use Bernoulli's equation. So let's get a new workbook. Let's keep this second velocity of 0.75 meters per second. And then Bernoulli's equation says that the pressure of one section plus half times the density times the velocity of that section squared plus the density of, in this case, water, the acceleration due to gravity times the height of that pipe. This is going to be held constant. So if we were to say this, that means that this entire sum is going to be equal to the sum at the second part of the pipe. And again, P sub 1 here is the gauge pressure. So here it would simply be half P sub 1 V2 squared plus density times gravity H sub 2. Now here we know the density of water is going to be 1,000 kilograms per meter cubed. And we simply have to isolate this variable right here because they're asking for the gauge pressure in the second section of the pipe. So P sub 2 would simply be equal to P sub 1 and then plus half of the density times V sub 1 squared minus V sub 2 squared plus the density times the gravity of H sub 1 minus H sub 2. Here they said, they have told us that the H sub 1, that the height difference, or rather delta H, is going to be 11 meters. We are given as well the initial gauge pressure of 5 times 10 to the 4th pascals. And at this point, we can solve for this. So P sub 2 is simply going to be equal to the initial gauge pressure of 5 times 10 to the 4th pascals plus half the density of water, 1,000 kilograms per meter cubed, times the difference in the squares of the velocities. So this would be 3 squared minus 0.75 squared, plus, of course, the density, again, 1,000. The acceleration of gravity due to the Earth is going to be 9.8. And then delta H here is going to be 11. So for this entire term here, this entire term is simply 11 meters, because that is the height difference between the first section and the second section of the pipe. Now we simply need to plug this into a calculator, and we find that the gauge pressure here is going to be 1.62 times 10 to the 5th pascals. So this would be the gauge pressure in the second section of the pipe. And that's the end of the solution. Thank you for watching.